Bismillahirrahmanirrahim. Now, the surface area of a cone is one of the trickiest questions for many students to solve. The volume of the cone and is like a volume of a pyramid is easy. Volume is 1/3 area of the base times the height. Okay, that's going to be 1/3 area of this base times this height. Okay, and that's pretty easy. That's the same principle for the cone as is for a pyramid. The surface area is tricky. The surface area of a cone, let's divide this. Let's figure this out. It is the area of the circle, okay, right? Area of this circle right here, right? Plus the area of the cone itself, right? And that's kind of like the if kids have the party hat, so is the surface area of the party hat, okay, of the cap itself, right? So, and that's this thing. If I could just kind of like try to draw this out, that's the surface area of the actual outside cone itself. So that's the total surface area. So the surface area of the cone is going to be the area of the base plus the lateral area, which is the area of the party hat. Okay, so lateral area, okay, which is the cone part of the cone. So this is easy enough, right? The question is, how do you find the area of the lateral area of this cone? Okay. Now, that's the tricky part. Now, the analogy to this is this, all right? If you remember, if you had a cylinder like this, all right, then the total surface of a cylinder were the two bases. You got this base and that base, and then you had the lateral area, which was the side of the cone, okay, which is the side of the cylinder. And if you recall, if you were to take the side of the cylinder and if you were to open this up, right, and then let me make this red over here at the top. And then what you would see is that you would have, when you open this can up, right, you could do, if you had a Gatorade bottle or something, if you open the thing, you get a rectangle. So you get a rectangle if you open this up. Now the question is, what do you get when you open up a cone? So if you have a party hat, this actually helps. If you have a party hat, if you open this cone up, in other words, if you take some little scissors over here, all right, so you take scissors over here and start cutting it right here, party hat like this over here, the question is, what do you get? Okay, so what do you get when you open up the cone? Okay, now, if you say that to students, many students say, then you might get a circle. Some of them might say you might get like a semicircle or something like that. Okay, but what you really get, when you open up the cone is this. Now, to illustrate this, what I'm going to do is I'm going to make this bottom circle like red, okay, like this. Okay, like this. So I'm going to make the bottom circle. So when you open this up, what you get is this. Okay, the lipstick part, so to speak. I'm sorry, the lipstick part, the bottom part of the cone, is going to be like this. Okay. All right, and then the sides are going to be like this. Okay. All right. So what you get, you see, it's not a circle, it's not a semicircle, but what you get is a sector. Okay, you get a sector. Now, if you remember what a sector is like it's like a slice of a pizza. That's what a sector is. It's on two sides, it has the radius of the circle, and this side is an arc. So this is an arc, and that's the two sides. So what you get when you open up a cone is actually a slice of pizza. You get a slice of pizza, which is a sector. In geometry, that's called a sector. But the question is, what pizza? Okay, how big is the pizza? Is this a big pizza, a small pizza, little Caesar? What kind of pizza is this? It's a big pizza. Let me tell you, it's a big pizza. It's not a medium size, it's a big pizza. Because what's the radius of this pizza? Not this. Now, you might be tempted to say the radius is this or something. No. The radius of this big pizza, large size pizza, is, let me give you time to think. What's the radius of this big pizza? And if you said the radius of this big pizza is S, then you would be absolutely correct. That's this. So when you open up the sides of the cone, you get a sector, which is a slice of pizza. Right? What pizza? An imaginary pizza. You don't have the rest of the pizza, right? Because it's gone. All you got is the sector. You got this piece left. Everything else is gone. But the radius of that pizza is S, right? All right. So then, if you want to find the area of this sector, then you have to go about how do you find the area of a sector? Okay, how do you find the area of a sector? What you did was you took the arc length, okay, divided by the circumference of the circle. Okay, if you take the arc length and divide by the circumference of the circle, okay, times the area of the circle. Okay, now I'm going to slow down for there for a second. Okay, the objective here is to find the area of this pizza slice, okay, of this sector, right? The way you do that, is you have to understand how you calculate the area of any sector. You find the area of the circle, whatever circle it is, and you take the proportion of that. Okay, if it's 90 degrees, it's going to be 1/4, right? Right? If you have half of it, it's going to be 1/2. You take the proportion of it. But what proportion of it do you take? Okay, either you take the angle proportion if it's 90 over 360, right? It'd be 1/4 of it, or 60 over 360. It doesn't matter what. Or you take the proportion of the length. If you know the angle's great, but if you know the length, you could take the proportion of the length. Okay, in this case, it's going to be the baby arc length. It's going to be this arc length over the whole circumference. Okay, this is going to be 1/4 of the whole thing either way, right? So you take the arc length and you divide it by the circumference. That's the proportion of the area that you're going to have. Okay, so to find the area of this sector, okay, so the area of this sector, okay, or the lateral, which is the lateral area of the cone, it's going to be some proportion of the area of the big circle. And what's the area of the big circle? It's going to be pi r squared. But what's r? R is s squared. That's the radius. Radius is s. Okay, so the area of the big circle is pi s squared. Okay, and what proportion are you going to take? You're going to take proportion, right? You're going to take part of it. You're going to take the arc length over here compared to the big circumference. So what's the arc length over here? Well, the lipstick part, right? That's the circumference of the baby circle. Okay, that's the circumference of it. That's 2 pi r. That's the little r. That, and over the circumference of the big circle. What's the circumference of the big circle? That's 2 pi s, right? You follow? That's 2 pi s. Okay, so if you simplify this, you see you get this and this. All right, right, and then you get this s goes with that s. You get r times pi times s. Okay, that's the area of the sector. Okay, so that's the lateral area. So the total surface area, is going to be area of this base, which was the easy part of this question, which is going to be pi baby r squared, plus the lateral area. The lateral area was the baby radius circle times the slant height times the pi. So the total surface area of the cone, total surface area of the cone is done in these two parts. You take the area of the base and you calculate the lateral area. The lateral area is trickier because this is the equation for doing it. But if you understand the rationale for it, it's actually quite easy in that way. I hope that helps. Until next time, then, as-salatu was-salamu ala rasulillah wa rahmatullahi wa barakatuh. Assalamu alaikum.